Astronomers and astrophysicists have long been fascinated by Betelgeuse, a massive red supergiant star in the Orion constellation that is a unique phenomenon in the universe. It would be larger than Jupiter's orbit and far larger than our Sun if it were located in the center of our solar system. In addition to having a huge physical presence, this gigantic star is going through significant changes that could result in an unprecedented occurrence. As Betelgeuse has been sending menacing signals across space, several academics have expressed their concerns, including renowned physicist Brian Cox. The main question raised by these developments is if a dramatic explosion that could forever change the night skies look is imminent. Astronomers are still fascinated by Betelgeuse's enigma. Like people, stars are born, grow, and die in ways that are frequently difficult for us to understand. Because of its enormous size and advanced age, Betelgeuse, a red supergiant located at the furthest border of our galaxy, has captivated scientists. Professional and amateur stargazers have long been drawn to it because of its reddish tinge and fluctuating brilliance. Researchers have been interested in its varying color and brilliance over the years, but recent occurrences have made these concerns for its future more pressing. Betelgeuse's enormous size near the end of its life cycle is a glaring indication that it will soon perish. It is around 1,000 times as big as the Sun. In fact, if it were to take its place, its outer layers would reach far beyond Mars' orbit, devouring Earth, Venus, Mercury, and Mars in the process. Its enormous size reflects its place in stellar evolution as well as its current form. Now that the hydrogen fuel at its core has run out, Betelgeuse is cooling and expanding, which is a blatant sign that its time is running out. Though it may appear youthful by human standards, Betelgeuse is ancient when measured in terms of star lifetimes, with an estimated age of 8 to 8.5 million years. This star has undergone a number of significant changes over millions of years, changing from a fiery blue star to the cooler red supergiant that we observe today. A precise equilibrium between nuclear fusion and gravitational forces drives the changes in stars like Betelgeuse. Stars' life cycles are determined by these competing forces, which cause them to expand and contract. Because Betelgeuse's surface temperature is lower than that of hotter stars like the Sun, it has a characteristic red hue. Betelgeuse has a much lower surface temperature, roughly 3,500 Kelvin, than the Sun, which has a temperature about 5,500 Kelvin. Betelgeuse gets its distinctive red color from the longer wavelengths of light it emits due to its lower temperature. Beyond its visual worth, though, this hue shift gives scientists important information about the star's interior workings and continuous evolution. The color and brightness of Betelgeuse have fluctuated over time. Betelgeuse was formerly described as a yellow star in historical documents from ancient civilizations, including the Chinese and Romans. Arabic astronomers did not notice its change to red until the 9th century. The star's natural transition from a hotter, younger form to the cooler red giant it is now is reflected in this color shift. Betelgeuse is also categorized as a variable star, which means that its brightness changes over time. These variations, which have been noted over several centuries, include both short-term cycles that last a few days and longer-term trends that extend for several years. Betelgeuse's mystery is increased by the fluctuations in its brightness. Betelgeuse sometimes deviates from this standard, in contrast to other stars that exhibit regular brightness trends, indicating that intricate, poorly understood mechanisms may be at work within it. The surprising dimming of Betelgeuse in 2019 was one of the most noteworthy recent occurrences. As Betelgeuse's brightness drastically decreased, a phenomenon known as the Great Dimming rocked the scientific community. The star, which is usually among the brightest objects in the night sky, became dimmest in February 2020 after losing brightness at a pace of 0.01 magnitudes per day. Many people question what could be hurting the singer after seeing this abrupt transformation. The time lag between an incident happening and our observation of it is one of the difficulties in researching Betelgeuse. Because it takes more than 725 years for light from Betelgeuse to reach Earth, we are effectively viewing the star as it was in the past, rather than how it is now. It is challenging to precisely forecast or explain the star's oscillations in real time due to this temporal lag, which also makes it more difficult to track abrupt changes in its behavior. In response, astronomers have been utilizing cutting-edge instruments like the Hubble Space Telescope to closely observe the star, including Andrea Dupree from the Harvard Center for Astrophysics. These findings have shed important light on the alterations taking place in Betelgeuse's outer environment. The Hubble Space Telescope data showed that material was being ejected from Betelgeuse at about 200,000 miles per hour. The star dimmed as a result of the dust cloud created by this material outflow, which partially covered the star's surface. Because of the speed at which this mass loss has been seen, there is conjecture that Betelgeuse may be about to experience a much more severe and massive event, a supernova. The crucial query still stands: will Betelgeuse detonate in a supernova? If Betelgeuse were to reach this level, its explosion would release an incredible blast of light that would be visible even during the day. A supernova is the terrible death of a star. An occasion like that would be more brilliant than the full moon and offer a rare chance to observe the latter hours of a huge star's life. But even though a supernova would produce a spectacular display, Betelgeuse is so far away from Earth, roughly 725 light-years, that there would be no immediate danger. The quick dimming shown in Betelgeuse has been explained by a number of ideas. It is commonly believed to be the start of the star's journey toward becoming a supernova. A cloud of dust created by the star's continuous material loss could also be obstructing its light. Last but not least, some scientists think the dimming might be brought on by modifications to Betelgeuse's photosphere or outer layer, perhaps as a result of the development of a large dark patch on its surface. Whatever the reason, Betelgeuse's fading continues to be a major area of interest for astronomers. Betelgeuse and other red supergiants are essential to our comprehension of star evolution. The last stage of a giant star's existence before it bursts into a supernova is represented by these stars. They are perfect subjects for researching the mechanisms that result in a star's demise because of their small and short lifespans. Furthermore, the energy that these stars emit in their last phases helps to create heavy elements, which are necessary for the formation of planets and life as we know it. In the event that Betelgeuse exploded, it would offer a unique chance to witness a supernova up close. In order to create new stars, planets, and maybe life, supernovae are essential for adding heavy elements to the interstellar medium. Betelgeuse's future supernova may offer a stunning display for stargazers worldwide, in addition to potentially having significant ramifications for our comprehension of these cosmic occurrences. Despite the possibility of a supernova, Betelgeuse is so far from Earth that we are protected from any negative consequences. Nonetheless, research on the star's dimming and eventual destruction will continue to provide important new information about the more general mechanisms influencing stellar evolution. The future of galaxies and star systems is significantly shaped by the spectacular deaths of red supergiants like Betelgeuse, which also provide important hints about the evolution of the universe. The information gleaned from this famous star will surely provide fresh insights into the larger subject of stellar evolution as astronomers continue to track Betelgeuse's changes. An important source of knowledge regarding the life and death of huge stars is the study of red supergiants and their ultimate destiny. Scientists can more accurately forecast the life cycles of other stars' comparable phases of evolution by comprehending the mechanics underlying these activities. The behavior of Betelgeuse might also shed light on the enigmatic elements influencing star fluctuation. In order to improve models of stellar behavior, astronomers will probably use Betelgeuse as a benchmark, contrasting its oscillations with those of other stars. Betelgeuse's mass loss provides insight into the harsh circumstances these actors face. The outer layers of Betelgeuse will probably become progressively more unstable as it gets closer to the conclusion of its existence, which will lead to further material loss. It is essential to comprehend this mass loss in order to forecast the evolution of other red supergiants. In addition to inspiring cosmic events, supernovae are essential for the universe's heavy element production. Iron, carbon, and oxygen, the building materials for new planets, stars, and maybe life itself, are released when a big star like Betelgeuse explodes. Should Betelgeuse explode, it will enrich the interstellar medium and open the door for new star systems, contributing to this cosmic cycle. By compressing surrounding gas clouds, a supernova's shock waves can create new stars, and the radiation emitted during the explosion might affect the chemical makeup of these new stars and planets. Gaining insight into these processes is essential to comprehending the universe's future. Astronomers will step up their attempts to investigate Betelgeuse using the Hubble Space Telescope and other cutting-edge observatories as it continues to change and show odd behavior. Our models of stellar evolution will be improved by the vital information these real-time observations will supply, especially in the areas of mass loss, brightness variability, and other processes that define the life cycles of large stars. In conclusion, studying Betelgeuse provides a priceless chance to gain a deeper understanding of the life and death of stars, especially ones that are significantly bigger than our Sun. Even though our Sun is a long-lived, medium-sized star, we may better forecast the fate of other huge stars in the cosmos by studying the behavior of red supergiants like Betelgeuse. Furthermore, we can gain a deeper knowledge of cosmic dynamics like star clusters, planetary systems, and galaxy formation by studying Betelgeuse. We will learn more about the basic mechanisms governing the cosmos as we continue to observe Betelgeuse and other red supergiants, which will enable us to tackle some of the most important astronomical topics. Beyond the thrill of Betelgeuse's possible supernova explosion, this star provides a unique window into the last phases of stellar development. Its enormous size, erratic behavior, and imminent demise offer important insights into the evolution and eventual demise of stars. In addition to helping us comprehend the complexities of the particular star, Betelgeuse research illuminates the life cycles of other huge stars and their ensuing effects on the universe at large. Scientists continue to examine Betelgeuse as a natural laboratory for stellar death as they track its evolution. We can better understand how other stars of comparable size and composition follow the same trajectory if we understand how it becomes a supernova. If that happens, supernovae are important occurrences in a star's life cycle and a turning point in the dynamic process of the universe's continuous expansion. Astronomers can improve their predictions of how red supergiants behave as their lifetimes come to an end by examining Betelgeuse's behavior, especially its abrupt dimming and changing brilliance. Betelgeuse is a crucial component in comprehending stellar death and the cosmic mechanisms that control it, even though the precise reason for its recent dimming is yet unknown. Another interesting feature of Betelgeuse's last years is the notable mass decrease that was noted. Scientists can discover more about the life expectancy and ultimate fate of similar stars because the star releases material at such a rapid rate. In addition to signaling Betelgeuse's impending demise, this mass loss advances our knowledge of how red supergiants affect their surroundings. Eventually, the star's ejected material will mix with the interstellar medium and affect the creation of new planets, stars, and other celestial bodies. New information on Betelgeuse is continuously being gathered by astronomers using both space-based observatories and ground-based telescopes. They are able to learn more about the behavior and internal changes of the star through observations made using tools such as the Hubble Space Telescope. Scientists can better monitor how stars like Betelgeuse interact with their surroundings thanks to these research, particularly as they near the end of their lives. They also provide fresh perspectives on how the overall structure of our galaxy is shaped by the fast mass loss and fluctuating brightness of these stars. There is special attention in the mass loss from Betelgeuse. The surrounding interstellar medium is greatly impacted by the massive amounts of material that red supergiants like Betelgeuse release into space. Heavy elements, which are necessary for the development of future stars and planetary systems, are added to the medium via this process. These elements help create the foundation for future planets, stars, and possibly even life when they are released into space. Astronomers are well aware that Betelgeuse's future supernova may lead to the formation of additional stars as it progresses through the later stages of its stellar evolution. Massive quantities of energy would be released during the explosion, compressing surrounding gas clouds and encouraging the creation of new celestial bodies. It is one of the main processes by which the universe regenerates itself, producing the building blocks for the stars and planets of the future. While the possibility of a supernova is exciting, there is little chance that it will directly endanger Earth. Since Betelgeuse is 725 light-years away from Earth, any dangerous radiation or shock waves would not be able to reach us. Nonetheless, the observational data acquired throughout this process will continue to yield a multitude of insights into the evolution, death, and eventual contribution of stars to the universe's life cycle. These discoveries will aid in our comprehension of the potential effects of upcoming stellar events on other star systems in our galaxy. Astronomers will closely examine Betelgeuse's imminent demise, whether it be by supernova or another catastrophe, not only because it offers a lot of information, but also because it exemplifies the general ideas of stellar evolution. Scientists can improve their models of stellar life cycles and the processes that take place when a star runs out of fuel by learning more about how stars of all sizes age and eventually die from the star's behavior as it approaches its conclusion.